Let's talk about one of the most fundamental ideas in all of math, and really the entire universe, functions. Now that word might sound a little intimidating, but I promise you, it's actually a beautifully simple and powerful concept. It's like a secret language that governs everything from your phone's GPS to the orbits of planets. So let's dive in and decode it together.
So just think for a second about all the billions of equations you could possibly write down. What is it that makes some of them so useful and predictable, while others are, well, they're just a jumble of variables? What exactly makes an equation special? That is the question we're here to answer.
And here's how we're going to do it. We're going to break it down into 4 simple pieces. First up, we'll nail down what a function is. Then we'll learn to speak its language. After that, we'll go on a little treasure hunt for something called its roots. And finally, we'll figure out its boundaries. It's a clear roadmap to really getting this stuff.
Okay, let's get right into it. Part 1. What in the world is a function? It honestly all boils down to one single core rule. If you can remember this one thing, you've pretty much got the whole concept down.
And here it is, the big rule. A function is just an equation where for any input x that you put in, you get back exactly one output y. Not 2, not 3, not 0, just 1. That's it. That simple idea. One input leads to one predictable output. That is the secret sauce to the entire thing.
Let's make this super clear. Take a look at the left. Y equals x squared plus 1. No matter what number you plug in for x, you're only ever going to get one answer for y. It follows the rule. It's a function. But now look at the equation on the right. With y squared equals x plus 1, if you plug in x equals 3, well, y could be 2, or it could be negative 2. You see that? One input, x equals 3, just gave us 2 different outputs. That breaks our main rule, so nope, not a function.
Okay, so now that we know what a function is, let's learn how to speak its language. And don't worry, this isn't some crazy new kind of math. It's really just a shorthand, a way more efficient way to write things down.
So you'll see this all the time. Instead of just writing y, we'll often write f of x. Now, don't let the parentheses fool you. This does not mean f times x. You say it out loud as f of x, and it's basically just a fancy label. It tells us, hey, we've got a function here, we're calling it f, and its value depends on the variable x.
And that letter f, it's not special at all. You can name your functions whatever you want. F of x, g of x, h of x. It's just like giving people different names so you can tell them apart. As you can see here, they all represent the exact same equation. We've just given them unique labels.
Okay, great. It's a new label, but so what? How does this notation actually help us? What's the point?
Well, this is where it gets really useful. It gives us a super clean way to evaluate a function. You can think of it like a simple recipe. Step 1, you start with your function. Step 2, you decide what you want to plug in. Here, we're asking for f of negative 3. Step 3, and this is the key, you replace every single x in the equation with your input. And finally, step 4, you just do the math. Let's actually do it. To find f of negative 3, we swap every x for a negative 3. So 2x squared becomes 2 times negative 3 squared. Well, negative 3 squared is 9, times 2 is 18. Then, negative 5x becomes negative 5 times negative 3. That's a positive 15. Tack on the plus 3 at the end, and you get 36. See, one input, negative 3, gives us one predictable output, 36. It works.
Awesome. Now we're going to build on that idea. We're going to go on a hunt for something called a function's roots. You can think of roots as the hidden clues or the secret solutions baked right into the function itself. They're incredibly important.
So what exactly is a root? It's really simple. A root is just an input value, an x, that makes the whole function spit out a 0. So when someone says find the roots, all they're really asking you to do is solve the equation f of x equals 0. That's it.
All right, let's get our hands dirty with an example. We're being asked to find the roots of this function. And again, that's just a fancy way of saying, hey, what values of t can we plug into this equation to make the whole thing equal 0?
Now, before you start panicking, here is the #1 pro tip for finding roots. The very first thing you should always try to do is factor the equation as much as you possibly can. This one move is the key that can unlock the entire problem.
So let's follow that advice. First, we set our function equal to 0. Then we look for something we can factor out. In this case, we can pull out a 3t. And look what that does. Now we have two things being multiplied together to equal 0. And the only way that can happen in math is if either the first part is 0 or the second part is 0. We just turned one big, ugly problem into two much smaller, manageable ones.
And that first part is super easy, right? If 3t equals 0, then t has to be 0. Boom, that's our first root. Now, for that second chunk in the parentheses, that's a quadratic equation. And to solve that, we bring in a special tool called the quadratic formula. It's literally designed for this exact job. All right, for our final piece of the puzzle, let's talk about a function's boundaries. You see, every function has its own set of rules, a set of allowed numbers you can put in, and a set of possible numbers that can come out. We're basically defining the playground where the function gets to live.
And these boundaries have two special names, domain and range. The domain is just the complete set of all the possible inputs you're allowed to use. And the range? That's the complete set of all the possible outputs the function could ever give you back. So, domain is what goes in, range is what comes out. Simple as that.
So how do you find the domain? Well, a lot of the time, the easiest way is to figure out what's not allowed. In the world of real numbers, there are two cardinal sins, two big no-nos you can never ever commit. Number one, you can't divide by 0. And number two, you can't take the square root of a negative number.
So let's put that to the test. Look at this function. We've got a square root, which should immediately set off alarm bells for rule number 2. To keep everything legal, the stuff inside that square root, the 4 minus 7t, has to be 0 or positive. It cannot be negative.
And once we solve that little inequality, we find our boundary. T has to be less than or equal to 4/7. Any number that fits that rule is a perfectly valid input. It's in the domain. Any number bigger than that? Sorry, it's out of bounds.
So let's put all our pieces together. What did we learn? First, the golden rule of functions. One input, exactly one output. Second, f of x notation isn't scary, it's just a useful label. Third, a function's roots are the special inputs that make the whole thing equal 0. And finally, the domain and range define the function's entire playground, what goes in and what comes out.
And there you have it, a quick guide to the world of functions. Now that you know the core rule, that simple idea of one input leading to one predictable output, I'll leave you with this question. What part of your world is secretly a function? Think about it. Once you start looking, you'll realize they are absolutely everywhere.